Good morning, everybody. I hope we are live. Today we will start recursion mastery and we will try to understand recursion through various lectures. We will try to go into the very depths of how recursion works, thinking of problems in terms of smaller problems. Let's say you are given a problem and what we are trying to do is, let's say we have a problem, we will try to break it in terms of sub problems and maybe solve those. We will try to generate solutions, generate different problems from a given problem, go through every step in a DFS fashion or any other fashion of traversal, solve smaller problems, combine them in order to solve a bigger problem. Recursion is not only useful in these sub-problem based solutions, it can be, it is, you can imagine it as some programming paradigm that is a way of solving problems. Like, yes, let's consider that you have an array, you just want to reverse it. Or maybe you have a linked list and you want to reverse it. These can be done through recursion. These problems can be thought in a recursive fashion. Yes, it's not necessary. Of course, you can reverse an array using a simple loop. But I am trying to teach you how to think problems in terms of recursion. And this will be useful when you are trying to solve harder problems, like maybe generate subsets. Out of subsets, pick only a specific subset, or maybe generate some, or maybe create a subset that matches a specific condition. It, like for example, let's say you are given an array, and let's say this, and this maybe makes up a solution. You want to generate every subset, or maybe choose a part of it that makes up the solution. So a lot of problems can be solved using recursion, and we will try to go through each of them. And we'll try to master recursion through a lot of problems. Like you can say we will be solving around 20 different kinds of problems in order to understand depths. After recursion, we will go through the backtracking paradigm. And trust me, backtracking will become much easier when you understand the crux of recursion and the way how it works, how subclasses are created and all. Let's see if the stream is running well. Okay, it's running well. So let's get started. So first, we will try to understand what is recursion. Of course, everybody is probably fairly familiar with the definition that recursion is just function calling itself. Let's say this is a function. I hope you know what function are. If you don't, just Google it up or maybe watch a 2 or 3 minute videos. But I hope you know what a function is. Basically, let's say I'm trying to solve a problem and these are the steps of doing it. Every time I'm trying to solve that problem, we don't want to repeat these statements again. So we will just block it up into some function and we will call that function again and again whenever we need it. Like for example, let's say this is my program flow execution, and let's say these 4 steps, like this S1, S2, S3, S4, S5, and let's say these steps are required here, here, and maybe here. So we don't want to write all these 4 steps or 5 steps here, here, and here again. So we will just make it into a function, and what this will be changed is if, then maybe whatever we have done, then if again, whatever we've done, then if again. So one line statement. Of course, the what will happen is, so let's say this is a function. I'm trying to explain why function is important. For example, and it executes, let's say, 5 statements. So S1 is, sorry, yeah, S1, S2, S3, S4, S5, let's say six statements a function. Let's call it F1 be a function that executes these six statements. And let's say I have a program flow that says that, okay, this is my program flow. And let's say I have some statements. And let's say I need S1, S2, S3, S4, S5, S6, maybe not enough doing something, maybe doing some other things. Then let's say we need this S1 to S6 again. And then maybe after doing some other things, we need S1 to S6 again. So you understand, so rather than writing S1 to S6 multiple times, we can just say that instead of this, what we will do, start with a bunch of statements. Instead of writing from S1 to S6, we will just call F1, right? And this will automatically do S1 to S6. Then, of course, we are done. Then again, F1 again, and then done, then F1 again. So you see, this kind of makes the code shorter. Every time I call F1, it will go here, uh, run all those six statements, and then it will come back. I hope it is making sense. So why this was the part, why functions are important. I hope you can understand my handwriting. So S1, S2. So basically, S function is basically a series of statements. Of- okay. So you have understood why function is important. Now, what is recursion then? So, so it's function calling itself. So let's say F1 be a function, and we have an F1. Let's say P1, and let's say P2. So same function with a different parameter this time. So this can be termed as recursion, function calling itself. But this is a very vague definition of what recursion is. Okay, let's try to select the stream. Okay, let's see if the stream is running well. Okay, it's running absolutely fine. So a function calling itself is just a very vague definition of what recursion is. Recursion, you can say, is much more than that. Mm, So you can think of recursion as maybe some problem. So function, you can imagine that a function solves a problem. That's how we look at function. A function or a method is something that solves a problem. So this is how we will look at function. A function is something that solves a problem. Then what is recursion? A problem that is trying to solve itself, but that is not possible, right? So we will try to define our problem in terms of some parameters. Let me give you a simple example. For example, imagine I want to say a problem can be print numbers. I know this is a very simple problem, but just hold on for some time. Print numbers from 1 to 100. Now, this is the problem. right? So let's say a function solves this problem. Now we want some function that solves this problem. So it can be like f, and it will take an integer n. And of course, I can just loop a for loop from 1 to 100, and I can just print the loop variable, and we are done. Like, so this f1 is a function that solves this problem. But you understand that there is no recursion here, right? So in recursion, this function tries to solve this problem itself. So you can imagine, like, let's say f1 will be calling itself with some different parameter other than n. Like say if n is 100, we don't want this n to be 100 again, because that will be an infinite problem. So 100 is the main problem statement. Let's imagine. So 100 numbers I have to print. So let my problem be defined in such a way, and this definition is important. Like I want to print numbers from 1 to 100, right? And I'm representing that problem as a function that if it is given 100, it will print from 1 to 100. If it is given 20, it will print 1 to 20. So we'll define this problem as function that is, if it is given 100, it will print from 1 to 100. If it is given 50, it will print from 1 to 50. So we have defined our problem in terms of functional parameters. So this 100 is a parameter. If it is passed to the function, it will print numbers from 1 to 100. Or I can just say function, if it is given n, it will print numbers from 1 to n. So this is how we have defined our problem to be solved by this function, right? Now we will introduce recursion. So this f1 problem, if it takes n, solves the problem from 1 to n, right? Now we have to call f1 again in order to solve some smaller problem. So I can just say that, okay, do one thing, solve n minus 1. So what this will do, it will print all the numbers from 1 to n minus 1. And then after that, I will say that, you know what, since from 1 to n minus 1 it is solved, I will just print n and I'm done. So I'm believing that this will print all the numbers from 1 to n minus 1, right? So this is recursively solving the problem by breaking the problem into smaller subproblems. So let's call this as calling itself with a smaller parameter set. It doesn't have to be smaller every time. We can bound them in other ways as well. So let's smaller, or you can say different. The different is important. We really cannot say that, you know what, solve this again. And it will just ask its next to solve the same problem again. That will be infinite problem. We want the parameter to change. So what you're saying that the function will call itself with a different parameter hoping that will solve that part, and I have to use this, assuming this is done. We have to do a small step, simple step, and that's it. Let's think about this. Of course, imagine that, let's say I give 100. 100 is saying, you know what, solve for 99. 99 will say solve for 98. This will continue up to 2 will say solve for 1. 1 will say solve for 0. 0 will say solve for minus 1. Right? So what's happening is 100 is saying 99, you solve itself yourself. 99 is saying 98, you solve yourself. Right? Let's say 100 is passed here. So what will happen is 2 will say, you know what? Solve for 1. After solving up to 1 is done, I will print 2 and I will give that control back to 3 who has called me. Right? So imagine like this. 100 says, you know what? Solve 99. And after 99 is solved, I will just print 100 after this 99 is solved. 99 is saying, you know what? 98, you solve yourself. After 1 to 9, sorry, after 1 to 98 is printed, I will just say, okay, you know what? 99 now I will print. After 1 to 98 is printed. So, and this will continue. So 2 will say 1, you print yourself. 1 will say 0, you print yourself. But we don't want this, right? Whenever someone says that, you know what? 1, you print yourself. We want to bound that in the end. That if this function is called for 1, then it will just print n and return. There is no further calling. This end case or bound case where we want the recursion to stop is called the base case. So I hope this base case is understood. So base case, of course, varies from problem to problem. For example, you want to mm, solve a very big problem. Let's say the problem is how many ways I can go from my hometown, or you can say how many ways I can go from a specific city, let's say Delhi, to my hometown, Bangalore. Now, a smaller problem would be I will check every place from where there is route from Delhi towards Bangalore, right? And you know what? After knowing from those places where I can reach Bangalore, I can just say, you know what? Append that Delhi to that part in the end and say this is the way. This is same as saying, let's say I want to reach from Delhi to Bangalore, and we want to count how many ways or maybe find out every way. So of course, from Delhi I will go to different places. So P1, P2, P3, P4, which are closer to Bangalore from Delhi. Of course, we don't want to go towards Kashmir or Uttarakhand. or West Bengal. We want to go south, not towards Gujarat. We will try to go towards Madhya Pradesh. Okay, if these terms are not making sense to you, if any international audience is watching, you can just take a look at the Indian map, how the states are located. That should be enough. So I'm just giving you an idea. No need to look up. So Delhi is kind of placed here. Bangalore is in the south. So we will try to go in this direction. We don't want to go northwards. We don't want to go this way. We don't want to go this way, right? And from these places, maybe we'll go to some other places. And from that other place, maybe this Bangalore is reachable, right? So we will ask Delhi, okay, but how can I reach? Okay, I hope this makes sense. A base case will be, let's say I'm reached this city from where I can directly reach Bangalore. This can be a base case. For example, printing numbers from 100 to 1. So if I've reached 1, that can be a base case. Or let's say I want to find out the number of ways to reach some stair n. We can just say that if I am already on the answer, my answer is 0 because I am already there. So no more steps are required. I will explain you all these problems. You can just say, imagine that base case is a simple problem that can be solved directly without solving any further subproblem. I hope this definition is making sense. So base case is a simple problem that can be solved directly without maybe calling the function itself again. I will give you the example. Uh, from the context that print numbers from 1 to 100. If 1 is called, print 1. No need to call further. Go back. So 1 can be considered as a base case. You can also say if 2 is called, print 2 and then 1, or print 1 and 2 and then return back. But we don't want 2 to be the base case. But if the person is calling for 1, the print numbers from 1 to 1, it only knows 2, so no. We want the base case to be as small as possible so that the lowest inputs can be covered. Of course, we will see this in code now. Let's go to VS Code. I will zoom this. Hmm, I can use my template directly, but this will be too complicated. These are just comments, so I can just ignore this. Um, I don't need solve. Yeah, the template is a little big. No need of fast away IO. Let's make a template out of this. Okay, now we have a very simple code. Of course, I need some includes. So we have a very simple C++ code. Let's imagine my problem is print numbers from 1 to n, where n is given as an input. Let's see if the stream is running well. So we basically want n, and we want to print numbers from 1 to n. Okay, I think I need to use the namespace. Otherwise, I would have to write std colon colon. Just shorthand. Anyways, so we want to write a function that kind of does that. So let's call that function is void. What should I call it? Pn maybe, or let's say, oh wait, that got disconnected. Okay. So where were we? Where were we? Yes. So mm, okay. So void prop. So it's a solve. Maybe it solves it for intent. Now, so basically this solves. We want to say that okay, if I know that it has been solved from 1 to n minus 1, so we'll call solve itself from n or n minus 1, and after printing up to n minus 1 is done, we'll just say cout n, and let's say maybe a space, right? But then what this will do is it will be it would run itself for forever. Like 100 will call 99, then 2, then 1, then 0, then minus 1. So we have to define a base case. So if this n is 1, we don't want to go back. We just want to say that print 1 or n, 1, and then return from here. No need to go to the other part. Of course, I could have said put this in yes else part as well. But if we just return from here, it should work. Just try to print, call this solve for this n that is given in input. Let's try to run this code. Hmm, let's say 5 I give as input. So you see it's printing from 1 to 5. Okay, change this. Okay, okay. So I think we have solved this problem. So this is the code. So what we're doing is solving it for some smaller sub problem, and and trying to solve the base cases. Let's check it for some other inputs as well. Mm, this G++ 15, but wait, some token is missing or something. Yes, I was asking for some input. Let's give it 20 maybe. So you see, from 1 to 20 is printed. Let's give it 1. So you see, 1 is printed. Maybe I can just make up a problem here and say that if what if the input is 1, run, input is 20, run. You see, you can install this extension. This is called the competitive CPH judge extension, available on normal VS Code extension store. Okay, then you don't have to use this code runner thingy. If you don't know how to set up this code runner CPH extension, just write down in the comment. I will make a separate video on how to do that. Or you can just search it up in YouTube. There are probably many videos explaining that how to set up VS Code for C++ or something. So we have understood what base cases are. We have understood what basically what recursion is. Now we will try to solve some problems. Let's say so print the sum of first n natural numbers. Of course, there is a formula of n into n plus 1 by 2, but let's say we don't know that. Also, we don't want to use loops. So basically, you can, if you have to use loops, then you can say the sum equal to 0 for I from 1 to n, sum plus equal to I, then just print sum. We don't want to do that either. We want to use the fact that what if the sum from 1 to n minus 1 is known? If I know that, I can just add in and say that that's the answer. You can pause and try to solve this yourself. Let's try to solve this now. Okay, so now we want this to return the sum of, so if n is 1, so the answer will be an int that should be returned. If you're wondering if something is written above or below, no, it's just comments. Okay, so if n is 1, we want to return 1. Okay, so 1 is the answer. Otherwise, this solve n minus 1 gives me the sum from 1 to n minus 1. And we want to return, so sum, let's say int, sum from 1 to n minus 1. Mm, So in sum from 1 to n minus 1 is this. So we just return n plus this sum from, right? So you see if I print 20, I mean run this for test case 20, I have to print this, right? You see 210 is printed. We can verify this, that the sum of numbers from 1 to 20 is 210. We can use the fact that 220 into 20 plus 1, that is 21 by 2, so 10. So 10 into 21 is 210, right? Okay. Uh, I think I should save this for you to maybe access later on. So this will be called P2, right? P2. And I want to duplicate this. And here, not paste. I think this will be P1, my problem one. And the problem was print numbers from 1 to n minus 1. Can I do an undo here? No. So I wanted to solve that, and this was void. No need to return. Solve n minus 1. I think this was the code for problem number 1. Okay, now we will try to solve P3. Let's see what the problem 3 says. So we have understood basic recursion. Now we will try to solve some complex problems. Recursions shines where subsets are there. So I'll explain subsets. If you don't know what subset is, I will recap it. Let's see how the stream is going on. Okay, the stream is running well. Let's continue. Let's say you are given a set. If you are familiar with high school mathematics, you know what subsets are. Let's consider this is a set A. That's set A, B, C, D. You know how many subsets or what are the subsets? Like let's say A dash, which is a subset of A. We mention it like as a subset of A. This means proper subset and this means a normal subset. Anyway, subset of A, that A dash can be A, it can be AB, it can be BD. Basically some part, not necessarily contiguous. Like sub-array means, of course, we're talking about sets, so there is no order to a set. So these are subsets. I will explain you a little bit more. Let's say you're given an array, not a set. You understand what subsets are in place of set. Basically, just pick some elements. You understand that 5 is also a subset, that I will take nothing. This says I will take B and D. So for every element, I have a choice. I want to take it or not take it. This time I decided to take B and D. This time I decided to take A and B. I could have chosen to take A and C and nothing else. I could have chosen to take all of them, or in this case, phi, I choose to take none of them. Of course, they have to be in order. Like AD and DA are considered the same subset. Like in sets, there is no point of order in a set. Let's take it in with the context of arrays now. Let's say an array contains 1, 2, 3, 4. So 1, 3 is a subset. 2, 4 is a subset. 2, 3 is a subset. 1, 3, 4 is a subset. How many subsets? This I have two choices, this I have two choices, this I have two choices, this I have two choices. So 2 to the power 4 subsets. For every from 5, so take nothing, 1, then 2, then 3, then 4, then 1, 2, up all the way up to 1, 2, 3, 4. Right? So this is a subset. And we will understand how to generate this subset using the help of recursion. So what we will do, let's say we are given this array 1, 2, 3, 4. So we'll go to every element and I will ask, do you want to keep it or maybe don't keep it? So what we will do is, let's say we are given this arrays and let's say I have two choices. So first I'm telling it index 1 or index 0 for the first element. We will say, do you want to keep it or not keep it? If I decide to keep it, so it is 1, 2. So my answer is now 1 and I am now on this location. I mean, this is the location where I will take the next decision. If I decide not to take it, then my array is empty. And now I'm supposed to take decision with. So index 1. So in the next level, we will take decision based on the second element. Okay. Now the second element also has two choices, take it or not take it. If I take it, it will become 1, 2. And in the next, I will take decision on index number 3. Here also I have two options, take or not take. If I decide to take, it will become 2. And if I don't take it, then nothing, right? Again, I have a choice. This is index 2. The next choice will be on index 3. I hope this is making sense. So at every level, we are deciding. Of course, I will show you how to do this in code. So in the first level, we are deciding that we want to keep the first element or not. Then we will say, you know what, decision for this level has been done. In the next level, we will take a decision on the second index or the index one. First index 0, then index 1, and so on. So you understand in the end, in this corner, after taking everything, we will have 1, 2, 3, 4, and in this end, we have nothing. Like take nothing, take nothing, take nothing, take nothing, or maybe some other branch, let's say 1, 3. So maybe 1 I have taken, and then I have not taken 2, and then I have taken 3, and then I have not taken 4, right? So you see, every possibility has been generated. Let's try to code it yourself if you can. I don't expect you to do it at this stage. I will show this to you, and maybe we will solve. Maybe you will solve the next one. Of course, you can give it a try by pausing this video if you are watching this later. Okay, so we are on problem 3. The problem 2, I think the question has changed. Print number, no, print sum of number. Okay. And problem 3 states print subset of a set. So, of course, we will have an array, right? So let's consider size n, and I can just say for I'm not here to teach you how to take inputs and outputs. I hope this should be language independent. Try to find your own way of taking inputs if you're doing it in Python or Java. Okay, so what we will do is for every index, so we will just say that uh, let's pass the array. So first we will have the index, next we'll have the array, and we will say we have to take decision based on the specific index. Let's have a global vector. So basically this will store the results. So every answer generated is an array itself, right? So all those arrays become an array of arrays. So vector of vector of int. So we will after let's say we arrive at, of course we don't need any return type. So we'll try to populate this result, right? What we will do is on this index, which will be initially 0, we'll take a decision. So do you want to push this in some temporary vector, or maybe not push this? So I can just have a new vector of int made maybe, right? So I have two options. Option 1, I think this mirror got disconnected. Anyways, so option one is take it. Take the element at index idx. So in this case, we will just inside the made, I will just push back my ARR idx, right? And I will just call this solve. You know what? Take the decision for the next of the elements. idx plus 1, ARR will go as it is, and mate will go as whatever we have made, right? But now this made at this current level is modified, and we have a new option that maybe not take it. You understand that made at this current level is modified. So we want to not take the index element, so I must remove it from this made because this made is modified at this level. I will explain you what this level means. What do I mean by made at this level? For example, let's say 1, 2, 3, 4, right? Now it is calling for index 0, this 1, 2, 3, 4 array, and made is initially empty. Now it says, okay, maybe take this. So what it has become 1, 2, 3, 4, the normal array, and made has become 1. And now we will take decision based on 2. Sorry, based on 1, first index. Now this call has come, right? Now on this, if I decide not to take it, so you see this call has come for index 0. Now I have pushed it into the made. So made has become this one thing. Now I want the same call happening without this one being pushed, right? So I must remove it from the made. I will show you, for example, let's say a call has been made to this 0, 1, 2, 3, 4 and empty using these parameters. What it has done is made this. Now after making this, I also want to say that in the next element, you have two options. Either I should pass 1, like let's say this is made. So let me explain you in a little bit more detail. Let's say I initially called for what parameters? 1, 2, 3, 4. Made is initially empty, and the decision is on 0th index. Now I have two options, either take or not take. So you see the lines are executing like this. At this position, we have made this, right? And let's say this has gone away. So this is passed to the next word with, so this is a branching place. After we have come down, either we pass it 2, sorry, 1, and 1, 2, 3, 4, and then and 1, or I want to pass 1, then take decision based on 1, and 1, 2, 3, 4, and then an empty. But in order to send empty from this position, I must empty this made vector, right? Like initially I called for 0th index. I made a change in the made, right? But what if I did not make any change in the made? Then again, in this place also, there should be two branches. Either I push 2 into the made, or maybe not push 2 into the made. So I've modified this made at this level, right? So this is the level I'm talking about. Try to think about it a little bit. You will understand. Drive this code in your head. So we should pop back before sending it to the next level because we don't want to. But you see, In the end, whatever choices we have done, we want to, in the end, if say index, so we don't want this index going forever. There is a bound to, otherwise this array of IDX will not be accessible if IDX is greater than equal to size of the ARR, right? So we want to say if IDX ever reaches ARR dot size, then we want to, whatever we have made, we want to push that made into our result. So you understand that this IDX equal to n can happen in all different ways in that tree. And after this, we read. There is no need of other option 1, option 2 if we have already reached IDX. So what we do is solve, call solve for 0 with the first IDX. I will send in this ARR and I will send in an empty array. And I will just print for driven subset through res for x through subset. Okay, let's try to print this for an array of size 4, and let's say 1, 2, 3, 4. You understand that these are all the same cases. In the first case, took all of them, then took all of this, but not the 4. Took 1, 2, but not 3, but 4. Of course, there is a way of arranging these in a good manner so that you will print all the one length subsets first, two length subset first. But that's not the point of discussion of today's lecture. Today's discussion is, please zoom it a little bit so that you can see it well. Should I print it out in a terminal? Let's print it out in the terminal. Say two, let's say 4 size. 1, 2, 3. Let's make it some other. No, 1, 2, 3, 4 is the best in order to understand subset cases. Can I full screen this somehow? Wait, where's the terminal? Yeah, yes. I hope these test cases are visible. So this was the input part. From this is where the output starts. I hope this makes sense. Let's see how long the stream is running. It is 59 minutes. So we have understood how to generate subsets. Now there can be a lot of problems on this topic. Like they can ask you, tell me which subset has sum 20, or maybe subset sum equal to some target. They can ask you a specific condition like how many subsets can be a part of some other subset. They can give you a string and say that there is string 1 is a subset or subsequence of the other string. So basically anything that is not subarray, subarrays are produced in a different manner. Anything that involves taking subset, taking an element, not taking an element, creating a subsequence, creating a subset. So option of taking, not taking, doing something, not doing something. basic recursion, I mean, will involve this kind of patterns. So option one, option two, there can be a third option as well. Maybe sometimes some options are not even valid. For example, we want to consider only those sequences that don't have consecutive ones or maybe consecutive zeros. In that case, we have to keep track of what is the last element that I took. So based on the last element, maybe I cannot take this element, right? So there could be restrictions. We will be solving all those kind of problems from the next lecture. This is just the first part. I hope you enjoyed the lecture. Let's see on let's see you on the next day. Have a great day. Like, share, subscribe. If you find